Hi Kotlin fans, thank you so much for joining me. We don't have a lot of time though, so let's get straight to it. First, take a photo of the slide. It contains the code, my coordinates, information about my new book. And second, I'm Josh Long. I'm your host, and I am very happy to talk to you about Bootiful Kotlin. My hope is that we'll spend the next 44.5 minutes together looking at Kotlin, some of its amazing ecosystem and its application in traditional Spring APIs, as well as in newer Kotlin first APIs and coroutines. Let's get to it. There's no doubt the role that Android has played to this day in making the Kotlin ecosystem the second largest after Java itself. So we can easily build Android applications by going to the Android Studio, which is a tool that's built by JetBrains and Google, and that builds upon the JetBrains IntelliJ project platform. And so I can build a new activity. Just click on this. I'm going to choose Kotlin. You can see it's the first supported language. Java is there still, but it's not the default anymore. I'm going to go ahead and hit next and just create a new application. And I'm not going to do much. I don't need to. This is not an Android tutorial. I'm sure you can find many more and many better besides. But what I'm going to do is I'm going to just customize it a little bit, and then we'll launch it in an emulator. And you'll see that this is actually a Gradle build. So it's using Gradle again, which is a very common occurrence throughout the Kotlin ecosystem. Not because it's the only choice, but because it's just a very popular choice, and there's a nice DSL in Kotlin and so on. Okay, so I've got the view. And I've got some, text. Let's just see. I suppose we can go to the resources file. So strings. Let's see. Strings dot whatever we want the file. Strings.xml. And here we're going to say first fragment, first Kotlin fragment. Okay. And then I'm just going to run it. And this is going to launch an emulator on my local machine. That's the. And there you go. It says first Kotlin 1. So it's very quick. It's very powerful, very productive environment. Kotlin Native is a way to write native code. We can open up IntelliJ and just create a brand new project like this. Click on New Project and choose Kotlin Native, right? So I'm going to say Kotlin. Let's see. We're going to call this. Let's call this Kotlin Native. Okay. And I'll put that in there. And then we can just choose a native application, choose a JDK. I'm happy with Java 11 here. This is for Gradle, mind you. I'm just choosing the version of Gradle, nothing else, right? The artifact of coordinates, just Bootiful Kotlin. All right, and then hit next. Everything else should be basically the same. We'll open that up in our IDE. Because you've got a Kotlin build file and you've got a Kotlin native application, and you can have Kotlin WebAssembly code and Kotlin JavaScript code and Kotlin, everything, right? Kotlin everywhere. So it's a really interesting opportunity here. Now, this is a simple public static void main kind of application, except that I have full access to things that you wouldn't think about, right? So let's actually write a little program here to read some data. Okay, so let's say I want to read lines. I'll say fun read lines for a path. And again, I'm using some types that are fairly familiar here, right? It's going to be turning a Kotlin list of string, right? And you can see I've got nothing there yet. So let's just say empty list for now. I could, by the way, I could also do to-do. I could use the macro, right? And this is one of the nice things about Kotlin, is that the language itself has this distinction between a function that returns void versus a function that returns nothing, right? So this function returns nothing. It's not the same as void. In Kotlin, when you want to express void, the traditional void in Java, you say unit. But if you want to say nothing, that tells the compiler this function will never return. It's not the same as it doesn't return anything. It's never going to return. And so the compiler can say, oh, well, if it's never going to return, then there's no need for me to bark at the user complaining about the fact that we don't have this type being returned yet, right? This type hasn't been returned. That's true, but the compiler knows we're never going to get past that function invocation anyway. Need to, provide implementation. Okay, so that's our very simple Kotlin native code. All I want to do is I want to read some data from a file, right? And so this, by the way, this thing here, this function, this is kind of like a macro, right? It's you can see it says inline only, and it's a public inline function. So essentially, when Kotlin sees this, it's going to copy and paste this code into the code base at the call site, like that, right? And so even in Java, if you do this in Java, it'll know that you can't possibly ever get to this line here, right? And even now you can see the IDE and Kotlin is saying, hey, this is unreachable. The same thing would apply for Java. But the difference is that in Java, if I call a function that will never return, Java doesn't know about that. So it'll continue to ask me why I didn't provide a return value after that function has been invoked or after that method has been invoked. So I've got this to-do macro. It's being copied and pasted into the call site. It's an inline function, and that allows me to flesh out what I'm trying to do here. I'm trying to read lines given a file system path. So let's create this function. Let's say, okay, hello world, of course, that's fine, we want that. But we also want to say path. And the path, I need to get that from I'm going to open up a text file on my desktop here, right? Test.txt. So I'm going to open that up, and so I need the home directory. Well, already I need to do something interesting. I need to read data from the environment variables in the operating system. So I'm going to say val home string, and notice that in Kotlin you have the variable name and then you have the type of the variable name, and then I'm going to say get env home, and this returns actually a pointer, right? You can see here it's a C pointer of byte var. So I need to tell it, hey, I don't want that. I want to dereference the potentially null thing and turn it into a K string. Okay, and if the K string doesn't exist, you can see, by the way, it's still upset with me, and the reason is because it thinks this might be null. If this is null, then I have to tell the compiler that these values might be null, this variable might be null, and I can do that by indicating with a question mark. Or I can force it to have a default value in the face of a null by using the Elvis operator, right? You can see it kind of looks like the swirl of Elvis's hair when he turned his head sideways. If you were to like look at it horizontally and imagine that his mouth is over here and his hair is over here, that's the Elvis operator, right? So now I've got a string that's going to either be a non-null reference to a value from the environment variables or an empty string. And with that, I want to invoke this function. I'll say read lines. And I'm going to pass in a path. I'm going to build a string based on this environment variable. So home desktop test.txt. And that'll give me a list of lines, right? So I say lines, right? So these are the lines. I could be explicit like I was here. I was explicit in declaring the variable types. I don't need to do that in Kotlin. It knows what the return value of a function is going to be, so it knows, and what the return value of the expression will be, so it knows that this could only ever be a string, right? But it's useful. Sometimes you may want to do that, so you can say list of string. And this is one of the things where I like Kotlin's approach to variables. It's always going to be VA question mark space and then the variable name. It'll never change, right? Unless you have a private or a visibility modifier. But really, all the variability happens after the VA bit. So it might be a val if the value is read-only or final rather, and it might be var, if the value can be changed after initialization. And the IDE highlights that with an underline, saying, hey, this is a non-final value. You can't be sure that it was initialized or that it hasn't been changed since initialization, which can be very useful. It helps you eliminate a whole cast of bugs. By default, I use val. So, okay, I'm reading lines, and I've got these lines, and I'm going to visit each one. And I could do a for loop kind of thing. I could say, whatever, I want to just visit each one. But it's so much more natural in Kotlin just to use these functions, these lambda functions. And so here, it's asking me to print out each item in the array. And if I wanted to do, if I wanted to like be like Java, I would say, okay, well, this is a function that takes a lambda parameter, and the lambda parameter itself has a single parameter. But the Kotlin way to do that is, first of all, I've only got one parameter to the lambda, so I can just drop the declaration altogether and reply upon the implicit parameter called it, right? This is from Groovy, very common. The other thing that you see here is that the lambda is the only parameter into the function, into the for each function. And so Kotlin doesn't care if I drop the closing parentheses. It'll do the same thing for the last parameter as well, right? So some interesting opportunities there. Now, what I want to do is I want to print out it. And did you see, by the way, when I didn't print out something, when I was just running the application and I ran this, it needs to be declared and used, or not declared and used. But if you don't declare it and you don't use it, it'll give you that little squiggly. If you just say underscore, that tells the compiler that you don't care about this variable. It exists, you acknowledge it exists, you just don't care about it, so just ignore it, right? So if I do this, I need to use it, right? And so that's why you get that squiggly underline in the for each there. Okay, so there's my code. I'm just printing out each record. Now, obviously we need to implement this because right now it's going to get to this point, it'll throw an exception, and that's not good. So we want to read the data from the file system. Well, here we're not going to be using Java I/O or anything like that, right? Because this is a native API. So what we're going to do is we're going to do fopen, and then we're going to take the path and we're going to read it. And you've probably used fopen in any of a number of places, right? If not in C and in low-level POSIX APIs, then certainly in the whole host of different languages that build upon the POSIX API and just literally forward to that native API. So Python and Perl and Ruby and all that all have PHP, all have functions that look virtually identical to the native C POSIX APIs, if for no other reason than to make it easier for people who've used those APIs to be able to script, right, to get their feet wet in scripting languages and still feel productive. In Java, we never really did that. We always just said we want to make it the Java way, and that's the only way, right? So everything looks a little different. If you've got 30 years of programming history and you've never used Java, it looks completely different. Nothing will line up with the mental model that most people writing for C or C++ or any scripting language thinks about things, which is, at least we have the benefit of some coherence in our APIs. On the other hand, it does mean we have to do some extra research. So I want to read the lines of this file into a list. So I'll create a mutable list of strings. Notice that this is a list of string, right? It's a list. It's also a mutable list, right? There's a whole secondary category of things. And if I declare the fact that it's a list of string on the left, I don't need to be explicit about the type argument on the right. It just gathers that. And then the reason that it can do this is because it understands generics in a slightly more sophisticated fashion than we have in Java. In this case, this is a little different, right? This is actually a little different than Java. It's basically the same for our purposes. We'll see later that it can actually do pseudo-reified generics, which you can't do in Java, right? So we have now lines, and what I want to do is I'm going to say, okay, let's visit each line in the file, okay? But in order to do this, I need to dynamically allocate an array, right? So I'm going to do an alloc, memory allocation for an array to store the bytes that I'm going to read from each line. In order to do that, I'm going to be adding memory, and I need to have something to tear down that memory to restore it when I'm done. Because remember, native APIs don't have garbage collection, and so that's reflected here in this very convenient mem scoped. So I'm going to say val buffer length equals 64. All right, I'm going to use 64 times 1024. And what I want to do is I want to say, okay, val buffer equals alloc array. Look at all these convenient functions here, right? And we're going to alloc an array of byte vars, okay, vars. And the length of the array is going to be buffer length. Voila. So there's my buffer. It's empty, of course. And what I want to do is I want to visit each line in that C file and read it into memory and then turn it into a string. So I'm going to say fgets, again, a low-level C API. And notice that as I'm importing these APIs, I get platform.posix.whatever. So fgets dot whatever. And here I say buffer. And I want to do buffer length, right, which is the last parameter, of course, is the file, right? So I'm going to read in from the file. This doesn't give me what I think it's going to give me. This gives me a C pointer of byte var, right? And so what I actually want is to turn that into a Kotlin string. And this is a nullable thing, no less. So I need to do two things. I need to safely dereference the pointer, which I can do with the question mark dot operator. That's a safe dereference. So it says if it's not null, then call this, otherwise return null, right? Rather than getting a null pointer exception. And that turns it into a K string. So now what I actually have here is a string. And I can do all the things that I want to do with it, just like I've done before. So what is the issue here? Oh, it's a nullable string. Right. Okay, so at this point, I need to either account for the fact that it's nullable or force it to to not be null. But obviously, in this case, it's important whether it's important that we know whether it's nullable or not. Because in C, this is how you tell if you're at the end of the file, right? So I need to say if next line should be null, or if the next line is empty, right? If it's got no string, no content, then break, okay? So you've seen code like this. I'm sure you've written code like this. This is low-level I/O, very, very simple kind of thing. Otherwise, I want to just add the data, add the string, right? Add the next line, and voila. And that's it. That's the basic logic of looping through a file and working with it. The only other thing is that while I'm in that loop, something might go wrong, right? And if that happens, I want to make sure that we clear up the memory associated with that file. So of course, I can use try finally, right? So finally, I'll say fclose. So we've got low-level APIs. We've got this interop that's made possible thanks to these Kotlin APIs. And you can see I've got support for pointers and memory and all that stuff, but I get this very high-level language, and I can work for most of my time in the code in terms of that language, right? And now with that, I'm able to just return the actual lines, and there we go. There's our Kotlin native application. So this gave us a chance to kind of see a lot of different things. Let's see if it worked. Looks like it worked. There's line 1, line 2, line 3. Obviously, I might want to do something. I might want to say, okay, well, for each line, map it to a trimmed string, and then recompile. There we go, cleaner. Not bad. So we have Kotlin native. Kotlin native is one possibility. It means you can write native code. I love that. The next thing that we're going to do is we're going to take a look at using Kotlin with Spring. So what we're going to do is we're going to go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. But if you haven't already begun your journey to production, you can begin it here at start.spring.io. Now, obviously, lots of stuff that we could do, but I'm not going to focus too much on all these different things. Hopefully, you've seen some of them before. What we care about is that we've chosen Kotlin, right, among these supported languages here. And then we're going to build a module called Basics. And here, we're not going to look at anything in particular. We're just going to look at existing Java APIs, APIs that long predate Kotlin and the current era. So I'm going to bring in the Postgres JDBC driver. I'm going to use the JDBC support in Spring Boot. And I think that's it. That's actually enough. Let's just start with that, huh? So these APIs, eventually we're going to make them talk to our SQL data store. And I've got a table here called customer. And you can see I've got some records in that table. So what I want to do is open up this in my IDE, and we'll just introduce a new service that we're going to use to talk to that data store. It's indexed, everything's ready to go. So let's go ahead and open this application up. What we're going to do is we're going to write some code that talks to our SQL database. So the first thing that we need to do, as with any Spring Boot application, is to connect to the SQL database, right? So spring.datasource.url, JDBC, :postgres QL, localhost orders, right? That's this. And we're going to say that the username is orders, and the password is also orders, right? There's the specification there. And now I'm going to create a simple service, just a very simple service, customer service. It's going to return all of the customer records within the SQL database. I'll say customer. And this is a type that I want, this customer. I could create a Java-like class. I could say class, customer, and then in Kotlin, in order to define a constructor, you say ID, integer, and name, string. And I could create, fields, private val ID, int. Actually, this is int, and I could do this kind of nonsense right here, private val name, string, name, all that kind of stuff. I could do that, certainly. Or I could use the init block to, do some validation. I could say, oh, well, throw an exception if something is weird. But all of this is way too much boilerplate for Kotlin. What I want really is just to assign fields. I want to assign storage to the constructor parameters. So I can say val. Now again, remember, val means read-only, var means mutable. This is going to create a public getter, but not a setter because there's no var. If it's var, then I'll get a setter and a getter. And since there's nothing in the body, I don't need that. What I do want is a toString and equals, a hash code, etc. So I can use data, and that creates a very simple, it's a thing for Kotlin that says, hey, just like in case classes with Scala, create a toString and equals, a hash code, all that stuff, right? So we have a lot of win there. Now, what I want to do is I want to create a simple JDBC template implementation of the customer service. So customer service. And I'm just going to inject my JDBC template. So JDBC template, right? This is a thing that comes from the, it's got to be in the constructor, right? Okay. The JDBC template's been around in the Spring ecosystem for decades, literally almost 20 years, right? It's one of the oldest types in the framework, and it is I think everybody's probably experienced or used it or worked with it. It's awesome, but it's old, and it long predates Kotlin, right? Kotlin's at most 10, 11 years old. So I'm going to use the JDBC template, and I'm going to implement it. I'm going to say, okay, return. I want to say this.jdbctemplate.query. Select all from customer, and I want to, I can use what I showed you earlier. The last thing that I want is to produce a RowMapper. Okay, a RowMapper takes a generic parameter, in this case customer, and it returns. I can use it to map the results into a shape. So I'll say, okay, return a customer, and the parameters for this are index, or the result set and index. So the lambda takes these two parameters. So I'll say, okay, use rs.getInt ID and use rs.getString name to build up the customer data. So I'll say return. But of course, I've got a function and it has an explicit return value. And then the first thing I do once I'm in the function is return a value. It's all in one fell swoop. So why can't the compiler make the leap between here and the results of here, right? Like it can actually. So that's the nice thing about Kotlin is if it's just an expression, if I'm just returning an expression, there's no need for me to be all that verbose about it. I can just say, okay, this function equals the result of whatever the expression that follows the equal sign is. The compiler knows that it's still implementing it satisfies the contract of this because query returns a list of T, in this case a list of customer because it's customers, and the contract requires a collection of T. So that works, it's fine, the compiler is happy. So now let's actually use this. Let's actually demonstrate it in action. And by the way, I've got a class up here and I've got a function down there, a top level function. These are not related to each other. I've got a class with no body, but this is the same as what I had before, just this, empty curly bracket, curly bracket. Remember, in Kotlin, you have functions and you have member functions, which are sort of akin to Java's methods, functions that exist inside of a class. So I'm going to say, okay, runner, and it's going to be a application listener that'll be invoked with the application ready event. And I'll use the CS customer service to do the work here. And I'm just going to say customer service.all.forEach println it. Okay, there you go. There's the entire runner. So let's go ahead and run this and see what we get. Good stuff. So there's the data from the database. It's working. Now, can we improve upon this? I think we can. Obviously, first of all, the compiler is saying, hey, this is a redundant constructor. You can get rid of that. We already know it's a lambda. Great. And remember, if it's a lambda, it can live outside of the function invocation. So I can hang it off the side there, and it's the same exact thing. It's kind of like a block in Ruby, right? The other thing that's nice is that, if we wanted to, we could actually do some very interesting things here. Let's suppose I wanted to do a parameter. Well, in the Java API version of this, let's say init this.jdbctemplate.query, there's a SQL string, and then the RowMapper goes second, right? And then on the end of that, then I have the ID. So let's say I wanted to do a query where it's like select all from foo where ID equals question mark, right? Well, the IDs go at the end, the parameters, and name equals this. So I have now a need for two query parameters. Well, that belongs in the Java API at the end because I want to have, I want to have like I want to have two different query parameters. I want to have two different things that get mapped to the question marks in the query string. This is a positional argument in the query string, but it's a variadic array in Java. And in Java, the variadic array you can have them, but they have to be the last, the last set of arguments, right? Well, that's not very Kotlin-esque because I have this big clunky lambda right in the middle of the function invocation. I have these little, these parameters at the end of it. So what they've done is that they've actually extended the existing type for us. So I can do this. Okay. Get rid of that. Good. Let's just say whatever, customer, who cares? One, okay, string, good. So now, do you see what's happening there? It's trying to give me an extension function. And that extension function I can import it just like that, and that extension function hangs off of an extra type that has nothing to do with the original JDBC operations, which is the interface for JdbcTemplate. These types are a Kotlin specific extension. So I can see it says string, then the variadic array, and then the lambda, right? And the lambda actually is a lambda. It's not an interface that can be converted to a lambda as with Java. It's an actual lambda, right? It's a function, a first class function, which is another thing that's very nice about Kotlin. So I can take these existing APIs and apply a fresh coat of paint to make them more Kotlin-esque, right? And it doesn't have to be to the detriment of the existing APIs. You can see I was able to do that without having to add a Kotlin-specific library. That code lives in the Java ecosystem, right? Oh, customers. It lives in the Spring ecosystem. It lives in the Spring framework jar. So I didn't have to do anything to get that extension function. It was visible to me and accessible to me as a Kotlin programmer. But if I'm using Java, I have the existing APIs, which work just fine and have worked just fine for almost 20 years. And there's no need for me to be so burdened with this extra API that it doesn't apply to me. So it doesn't appear in the auto completion or in IntelliSense or whatever in my IDE. So this is really powerful, right? I've got the ability with Kotlin to extend the existing APIs. Now, we've looked at how Kotlin makes, just by virtue of the language, it makes existing APIs nicer. We've also looked at how we can seamlessly sort of integrate newer Kotlin-esque APIs into existing Java APIs. We can hang extension functions off the side of them. One of the other really interesting opportunities is using Kotlin-specific APIs with Spring, right? So there's actually a very nice ORM called Exposed. Now, Exposed is a JetBrains RowMapper kind of thing. It's a ORM mapper thing that we need. And so I need to add it to the build. I'm going to go back to pom.xml. And we'll go down to here. We'll say add this. Now, the build, the repositories are JCenter. So I need to download the Kotlin Exposed. I need to connect to the Kotlin Exposed Maven repositories. But then I need to add the actual dependency. Now, this is a Spring Boot starter, right? It's an exposed Spring Boot starter that has auto configuration that makes most of the work of using Exposed trivial, right? So now I've got this on the class path. Let's go ahead and build an exposed version of the customer service called Exposed Customer Service, okay? And it's going to be a customer service implementation just as before. And we're going to implement the interface. We'll just say at override, at service. And here, in Exposed, you use a type safe DSL. So I need to create an object, not an XML config file, not annotations. I use an object to map my table structure to a Java API, or to the Kotlin API rather. And that object, I'm only going to ever use once. So it'd be a pity to have to define a class that then gets used but once. So in Kotlin, as with Scala, we have something called an object. It's a singleton, basically. So I can say object customers extends table. And table is a JetBrains exposed API, right? So val ID equals, and then here we're going to specify, we're going to recreate or redescribe the structure of my table. So it's an integer ID, and it's going to be auto incrementing. Great. Val name equals varchar name, and it'll be 255 characters, right? So good stuff. So there's that, right? And I'm now going to use that for my exposed customer service. But keep in mind, exposed has its own concept of a session, its own concept of a transaction. And so we need to be aware of that. And so what I like to do is I like to make my services transactional. The auto configuration automatically connects the transaction, the definition of a transaction from exposed to the definition of a transaction from Spring, right? So now I can easily just say, okay, return customers dot select all dot map, and here I'm going to say customer it customers dot ID it customers dot name. Okay, so I'm just returning a type safe version of it, and again I can just drop all this intermediate stuff, and I get the more svelte, more concise, more approachable version that I like. So that's very nice. I don't have any stringly typed service definitions here. I have just a nice type safe API. And of course I can do predicates, I can do filters and all that good stuff. So there's my exposed version of the API. Now we've seen the sort of sweep of what it looks like to do things in a traditional Spring application, right? And these are all sort of APIs that feel very approachable for Java developers, but that are just a little bit more friendly in the scope of Kotlin. In this section, we're going to take a look at using some of the more advanced Kotlin first DSLs. So thus far, we've looked at APIs that were designed for Java developers that happen to be accessible with just a soft touch extension function here and there, and not much else, right? These are APIs that work nicely given Kotlin and given the presence of the language, but are not designed for Kotlin. They're just extended to make it just that much more accessible for Kotlin. What I want to look at now is some of the DSLs and some of the opportunities that the language gives us to radically rethink the way we use APIs. And so what I'm going to do is I'm going to go ahead and go back to the Spring Initializer, and here we're going to build a reactive application. Okay, so we're going to just call this DSLs, and we're going to use Kotlin as before. And what I'm going to do is I'm going to bring in the reactive web support. I'll bring in the PostgreSQL support. I'll bring in R2DBC, and I think I'm happy with those selections. You know what else I want? I want gateway. There you go. So let's go ahead and hit generate. I've got Kotlin selected. I've got Java. What am I using? There you go. It doesn't matter. Hit generate. And I'm going to open this up in my IDE as before. So what I want to do is I want to take advantage of the reactive APIs that have been introduced in the Spring ecosystem. Now, reactive programming is it's an inversion of the normal paradigm of building services. Instead of using things like Java IO input stream, where the client must ask the input stream for the next byte and then wait for that next byte to arrive, instead we move to things like asynchronous IO, as embodied by things like Java NIO and Netty, that give us the ability to say, I want that data, please, and I expect it to be here, but it's not here right now, and it's fine if it gets here in a minute, and I'll just do something else in the meantime. I'll jump off of the thread on which I asked for that data and return that thread to the thread pool while I'm waiting for the response, while I'm waiting for the interrupt. Because it requires everything above the IO layer, well, the IO layer and then everything above it to change, because it has its fundamental change, the APIs are very different. You're not using input streams and Java collections. Instead, you're using these reactive types that come from the org reactive streams the org reactive that come from the org reactive streams package. So what we're going to do is we're going to build a new application, and this application is going to be a reactive web application and a reactive Spring Cloud Gateway application. Okay, so let's talk to a database first. We're going to use R2DBC, which is a reactive relational database connectivity abstraction. It's a reactive relational database connectivity abstraction. There are a number of different abstractions that we can use supporting SQL and NoSQL, but I want to use the R2DBC support because it gives us a nice API for working with SQL-based data stores. So what I'm going to do is I'm going to create a new type called a customer, and again, val ID int val name string, and that's the customer. And then I'm going to create a reactive repository. Okay, and I don't need to do anything special here to extend. I can just say reactive CRUD repository. And this is a Spring Boot-ism, right? Spring Data-ism. I can say, okay, this is a repository that'll provide methods that I can use to talk to my data store in terms of this interface. I don't have to actually implement the interface. Spring will do that for me, right? So I'll build an HTTP endpoint. And what I'm going to do is I'm going to build a functional reactive HTTP endpoint, so router, right? And here I'm going to use the functional reactive style. So I'll say I want to use HTTP routes, and I can use the Java DSL. I can do something like this, and I say routes.get, and I say customers, and I provide a handler function, and then I provide a server response .ok.body, and then I say build, right? And here I'm going to inject my collaborating object, my CR, my customer repository, and I'll return that here. I'll say cr.findAll. Okay. Now already we got some benefits here. First of all, this is an extension function. You can see that, and the reason we have an extension function is because in Kotlin I can actually capture generic information and reify it, which you can't do in Java, right? If you want to prove it, try using reflection. Try creating an array list, and then using reflection to you at runtime decide what the generic type of that array list is, the T in the array list, right? It's an array list of strings or an array list of ints or whatever. That's not going to be so easy, right? So you can do that by creating a subclass, right? But it's not really as elegant as we'd like. So we can capture that generic information at runtime, at compile time rather, because we have that aforementioned macro facility, that ability to sort of copy and paste the definition of the function at the call site, and therein capture or note the implied generic type at the compiler level at the call site as well. So here it's reified t, right? Reified t means capture the generic parameter t, and then make it so that I can actually invoke it or use it. And all we're doing here is we're capturing t and then creating a parameterized type reference. So it's very convenient. I mean, you can actually do something like t.class now, right? You can actually ask what t is. You can actually create a new t. You can say t.class. And then get the constructor or whatever and create new instances. So lots of options. Now, we've got this reified type. Already, that's not so bad, but there's actually a DSL that you can use that's available called router. And you can see I had to go out of my way to not use that because the IDE wants me to do the right thing here and use this nice DSL. So the DSL looks like this. I say customers, and I just say, okay, server response, paste, and voila. Okay, so there's that, and that works fine. Now what I also want to do is I want to use get, I want to create an endpoint for just a single record, customers ID, right? So server response.ok.body. And here I'm going to need the incoming request, right? Well, of course I can give it an explicit name, or I can just use it. I'm going to say it.path variable ID. And I'm going to use that to ask for a certain record by its ID. So I'll say cr.find by ID, and I have to pass in an int. So I'll say int, integer.parse int string, and voila. So there's my single response, right? If you look at what's happening here. Now behind the scenes, I'm making these calls to the repository. What I'm getting is a reactive stream. I'm getting a publisher of customer, right? It's a reactive type. It's not a customer. It's a publisher of customer. Ditto for this one. This is a publisher. So save that. It's a publisher. There are actually two specialized subtypes involved here. In this case, I'm probably getting a flux, which is one or more values. And here I'm getting a mono, which is a single value, but they're both ultimately just publishers. They're reactive types. So you have to know about these reactive APIs to work with them. You can't just start working on the return value of that function. You have to actually unpack the value implied by that publisher. A publisher is kind of like a future. It's not the thing you want. It's a thing you can get. It's a thing you can use to get the thing you want, right? That's asynchronous. That might be in the future. Okay, so now I've got this nice DSL, and you can see it's built for Kotlin. This is an extension function, but it's also a separate API. Another thing I might want to do with my functional reactive application is use Spring Cloud Gateway, right? Simple gateway. Now Spring Cloud Gateway is a route. It's an API gateway, and in order to use it, you use that route locator builder, routes.build, and again, I'm using kind of like the Java API. And here you define a route, and the route has a route spec, right? Like so. Route spec dot URI. And what I'm doing is I'm matching the incoming request. I'm saying if the incoming request coming to this node has a path of this, then I want to send it to, let's say, HTTPS spring.io/guides. Okay. Well, of course, guides in the outbound request, the incoming is going to have a path of path, or let's say proxy, even better, right? Or guides proxy. There you go. It's going to have an incoming path of guides proxy, but the outbound host and port is Spring.io, and the path is guide. So I need to mutate the incoming thing, and I can do that by configuring a filter spec, right? So I say filter spec.setPath to be guides, in which case I don't need to specify it again, it's implied. So that's my Java API. Now, of course, you can imagine there's a really nice Kotlin API. So what I'm going to do instead is I'll say, okay, .route path matches guides proxy filters, and we're going to say set path guides, and the URI is https spring.io. Much better, right? Much cleaner. Don't need the closing build because the scope is implied. So it's for this reason that Kotlin is really great for DSLs, right? Really, really great. Actually, there's another DSL that we've kind of left on the table here, and we should take advantage of. The API for registering Java beans themselves has been there's a functional or programmatic way to do it. And so the way that works is you say, okay, add initializer beans, right? Beans is a DSL in Kotlin. There's a Java API version of this, but in Kotlin, it's so much more elegant, I think. And then you just provide the return value, the thing that hangs off the end of the function, the body. That's the thing you're defining there. So that's this. Obviously, this depends upon a collaborating object called CR. So I'll say val CR equals ref customer repository, right? And that way I'm using the API to look up the thing. Okay. So this goes away. I no longer need that Java config. And over here, same thing. I need to take all that bean and val RLB equals ref route locator builder. Okay, same as before. So I'm just using the DSL here to look up the collaborating object. There we go. So now I get rid of all this too. How cool is that, huh? Now I can actually just define two different things and I can run them. Let's go ahead and see what that looks like. All right, I forgot to specify a connection query or connection string. So I'll do that here. R2DBC URL, right? R2DBC URL equals R2DBC Postgres, not QL. I always get that confused. It's QL for the JDBC, but not for this. And we say that the username is orders, and of course the password is orders, right? So now I restart. Cool. So there we go. There's my restarted application. It's connected to the database. It's up and running. Localhost 8080/customers. There's all the data. And here we go. Number 54. Did I do that wrong? Oh, I forgot to map it to an ID. So I need to say at ID. Okay, there we go. Restart. There we go. There's our single record. All right, so now that's that use case. What about the proxy? Well, guides proxy, wasn't it? There's our Spring IO guides and so on, and the HTML. But I didn't proxy the whole website. I literally proxied that one page, so it's not proxying the CSS and the images and all that stuff. But you could, is my point. So now we have a reactive application. You can see it's a very different thing. This doesn't look like Java at all, right? There's nothing you could change the package names, and this might become some other framework entirely. And yet we still get the benefits of Spring here. We're still using Spring underneath the hood. All right, so now we've got this. One last thing. We can use something called coroutines, right? Coroutines are a feature in Kotlin that make writing asynchronous code much easier. And the way it works behind the scenes is a little bit of compiler magic. There's actually some sorcery that has to happen to make it work. But the benefit, of course, is that you can write code that is asynchronous while feeling like it's regular imperative synchronous code, but it's not, right? Behind the scenes, it's still jumping off the thread. It's still being the most resource efficient version of the code possible. It's just different. So let's rework. We don't care about this one anymore. We've got one endpoint that'll work. Let's rework this. First of all, we need to use the coroutine router. Okay, this is a new API. And then second of all, I need to use coroutine support for reactive APIs. So I'm going to say await first, and that gives me a customer, right? So I no longer am dealing with a mono of customer. I'm dealing with just a customer. This isn't blocking. I'm not actually forcing the thread to come to a halt or anything like that. I'm still jumping off of the thread, but I don't have to worry about it anymore. And now I've got this coroutine value, and I say body value and await, and I publish that result in there, right? So customer. So now I've got this reactive code. It's still reactive under the hood. We're still getting the benefits of that, and that's what you would use in Java. But if you're in Kotlin land and you want to write very simple sort of code that it's not riddled with method chaining, and it's not riddled with callbacks like in the early days of Node.js, then you can do this, right? And you get the result very conveniently back here. And so we say customers 54, and there we go.